Today we shall discuss some NCERT problem of exercise 1.3 related to composite function. Exercise 1.3 question number 3. First, if fx is equal to mod x and gx is equal to mod 5x minus 2, find composite function of f and g and g and f. How we can find composite function of f and g and f if fx is equal to mod x and gx is equal to mod 5x minus 2. First of all, we find composite function of f and g. Composite function of f and g into x is equal to g into fx, which is equal to g into mod x and which is equal to mod 5 into mod x minus 2 is equal to mod 5x minus 2. This is the value of composite function f and g. Similarly, we find composite function of g and f, which is equal to f into gx and gx is equal to mod 5x minus 2 and f mod 5x minus 2 is equal to mod 5x minus 2 which is equal to mod 5x minus 2. So the value of composite function g and f into x is equal to mod 5x minus 2 and the value of composite function f and g is equal to mod 5x minus 2. In this problem, composite function of f and g and composite function of g and f are equal, but in general, composite function of two functions are not commutative. That means composite function of f and g and composite function of g and f are not equal. Now we discuss inverse of a function. What is inverse of a function? Inverse of a function. Let f is a function defined from a to b. If we follows a rule in which every element of B associate with unique element of A, then rule is called inverse of function f defined from B to A. It is denoted by f inverse is a function from B to A given by f inverse y is equal to x. X is called inverse image of y and y is called inverse pre-image of x. From this definition, it is clear that a function is invertible only when it is bijective. That means 1, 1 and 2. So we can say that only 1, 1 and 2 function has inverse function. In any problem, to find the inverse of a function, first of all, we have to prove that the function is invertible. That means we have to prove that the function is 1, 1 and 2 and then find the value of x in terms of y, which is called inverse of a function. So now we shall discuss how we can find the inverse of a function. Through definition of composite function, we also find the inverse of a function. Inverse of a function by composite function. Let f is a function defined from A to B be invertible function. If we define a function g from B to A such that if composite g into x is equal to IA and g composite f is equal to IY, then g is called inverse of if, where IA and IB are identity function. That means IA into x is equal to x and IB into y is equal to y. So in other way, we also find the inverse of a function by composite function. Next problems in exercise 1.3. Question number 4. In exercise 1.3, we shall discuss question number 4. If fx is equal to 4x plus 3 upon 6x minus 4 where x is not equal to 2 by 3, then find so that if composite f into x is equal to x, and also find the inverse of f. Solution: if composite f into x is equal to f into fx, according to the definition of composite function, this will be equal to f into 4x plus 3 divided by 6x minus 4, and since fx is equal to 4x plus 3 by 6x minus 4, therefore f into 4x plus 3 by 6x minus 4 is equal to 4 into 4x plus 3 by 6x minus 4 plus 3 divided by 6 into 4x plus 3 by 6x minus 4 minus 4, and this is equal to 16x plus 12 plus 18x minus 12 divided by 24x plus 18 minus 24x plus 16. 24 LCM, 12 LCM, and this is equal to 34x divided by 34 is equal to x. Therefore, if composite f into x is equal to x, proved. By the definition of inverse of a function through composite function, if f composite f into x is equal to x, then f is called the inverse of f. Therefore, inverse of f is equal to f inverse is equal to f. Question number 6. So that the function if defined from closed interval -1 to r given by fx is equal to x by x plus 2 is 1. Find the inverse of the function. Find the inverse of function if defined from closed interval -1 to range f. Solution of this problem is as follows. Since f is a function defined from closed interval minus 1, 1 to r given by fx is equal to x by x plus 2. Let x1, x2 be any two arbitrary elements of the domain of function f such that fx1 is equal to fx2. Since fx is equal to x by x plus 2, this implies that fx1 is equal to x1 by x1 plus 2 and fx2 is equal to x2 by x2 plus 2. This implies that x1, x2 plus 2x1 is equal to x1, x2 plus 2x2. This implies that 2x1 is equal to 2x2. This implies that x1 is equal to x2. Therefore, function f is 1, 1. Since codomain of f is equal to range of f, therefore f is unto, thus f is 1, 1 and 2. Therefore, function f is invertible. F is invertible. Let y belongs to ring f such that y is equal to fx is equal to x by x plus 2. This implies that xy plus 2y is equal to x. This implies that x into 1 minus y is equal to 2y. Therefore, x is equal to 2y by 1 minus y. This implies that f inverse y is equal to 2y by 1 minus y. Therefore, inverse of function f inverse of function f is equal to f inverse x is equal to 2x by 1 minus x. This is the solution of this problem. And next problem is question number 9. Consider f is a function defined from r plus 2 closed open interval minus 5 infinitive defined by fx is equal to 9x square plus 6x minus 5. 9x square plus 6x minus 5. So that f is invertible. So that f is invertible and find the inverse of f. To prove f is invertible, we have to prove that f is 1 onto function for 1 let x1 x2 belongs to R plus such that fx1 is equal to fx2. This implies that since fx is equal to 9x square plus 6x minus 5, therefore fx1 is equal to 9x1 square plus 6x1 minus 5, and fx2 is equal to 9x2 whole square plus 6 into x2 minus 5. So fx1 is equal to 9x1 whole square plus 6x1 minus 5, and fx2 is equal to 9x2 whole square plus 6x2 minus 5. This implies that 9 into x1 whole square minus x2 whole square plus 6 into x1 minus x2 is equal to 0. This implies that x1 minus x2, since x1 whole square minus x2 whole square is equal to x1 plus x2 into x1 minus x2. So taking common x1 minus x2, 9x1 plus 9x2 plus 6 is equal to 0. This implies that x1 minus x2 is equal to 0. This implies that x1 is equal to x2. Therefore, fx1 is equal to fx2. This implies that x1 is equal to x2 for all x1, x2 belongs to R plus. Therefore, function f is 1, 1. Therefore, function f is 1, 1. For unto since fx is equal to 9x square plus 6x minus 5, fx is equal to y, 9x square plus 6x minus 5. So this implies that 9x square plus 6x minus 5 minus y is equal to 0. This implies that 9x square plus 6x minus 5 plus y is equal to 0. This is quadratic equation in variable x. So find the value of x. Since the solution of quadratic equation ax square plus bx plus c is equal to 0 is x is equal to minus b plus minus under root b by 2a. Therefore, x is equal to minus 6 plus minus under root b square, that means 36 plus 4ac, 36 into 5 plus y divided by 2 into 9. This is equal to minus 1 plus minus under root 6a plus y divided by 3. This is the value of x, but x belongs to R plus, where R plus is the set of all non-negative real number. This implies that x is greater than or equal to 0. Therefore, x is equal to minus 1 plus under root 6 plus y by 3. Minus 1 minus under root 6 plus y is by 3 is rejected. Therefore, x is equal to minus 1 plus under root 6 plus y by 3. Since x is greater than or equal to 0, therefore minus 1 plus under root 6 plus y by 3 is greater than or equal to 0. This implies that minus 1 plus under root 6 plus y is greater than or equal to 0. 6 plus y is greater than or equal to 1. 6 plus y is greater than or equal to 1. This implies that y is greater than or equal to minus 5. Therefore, a range of f is equal to codomain of f. Therefore, thus f is 1 1 and 2. Therefore, f is invertible, and inverse of f is equal to f inverse y is equal to minus 1 plus under root 6 plus y by 3. Homework assignment: solve the problems in exercise 1.3.